Okay, this is just a video about updating the resource database for renewable energy, and I've got the wind generation database open. This has a database of power plants in the U.S. and we split it up between wind, hydro, and solar. And this time I sorted it kind of. I showed you, I have the units that have most data on the top and then subsequent data on the bottom. Now, the idea of this database is to look across and understand how much variation. Here's the variation in month by month data and the variation in year by year data. And if the DSCR is 2.0, so if we have 200 in cash flow and 100 in debt service, that means that the cash flow can fall down by 2, or we can have this idea that the percent reduction is equal to DSCR minus 1 divided by DSCR. Similarly, if we go the other way, I had to take a break, sorry about that already, just 1 minute into the video, but then we rearrange and say DSCR, move this to this side, and say DSR times the percent reduction is DSCR minus 1, move it over and kind of adjust the subtraction the other, and then you say DSCR times 1 minus the percent reduction is equal to 1, or DSCR is 1 divided by 1 divided by the percent reduction. So in this case, we have a P99 of 25, and we can say DSCR required for P99, I think I might leave this in the file, is equal to 1 divided by 1 minus this number. Okay, so we need at least a 1.33 DSCR. Now, in this database, it's got the historic production. Here, this one had an enormous percentage because of this line. So to meet that one, we needed a 3 times here. We needed a 1.2, 1.51. We can kind of, don't look at that one. Okay. And so here's here's some decent ones. We can kind of look at the average production relative to the P99 production and pretend that the average was P50, which is probably maybe not a very good idea. And you can see actual variation and what kind of DSCRs you need. And you can kind of compare the real reductions to the amounts that were projected in the resource studies. Now, this file is updated for 2016. And what I did is I put it in the wind resource assessment section, and because I really wanted to study this for wind first, I'm going to put the video here that we're making as well. But here's the way this works is the following steps to update this. You find the EIA database. Now, the EIA database is some monster database. It's got 201 megabytes or something. So I had to put it on the Google Drive. Here's the Google Drive link. Then we go, if we want to update this, we go to the EIA website, and they kind of have the latest year for the EIA 923 data. Now this, if everything was fine, everything was the same, this would be fine. But it goes back to 1970, And over the years, they've changed so many different codes and everything else. That was the real pain. And then what you do is you basically go into the EIA database that I don't even have open, and I suppose I'll open it here just to give you a... Okay, that took a little while to open. It's... I pressed F12 to save as, and this file has 219 megabytes, okay? And this file, if you look into it, there are all these adjustments to make to the plant name, but really, here's 2017. And for 2017, it's got 7,000 lines of different power plants. And for each power plant, it has over here some, let's look at 2016. How's that? 2016, that 2017 would have been fine. It's got consumption in megawatt hours, or that's consumption of fuel. So you could even compute the heat rate because you have the quantity of electricity, but it's got the quantity of, oh, come on, the net generation here. I'm sorry, I'm being an idiot and not being able to find it. Here's the BTUs, and here's the generation. Find net gen, January, February, March, April, May. And if you go all the way down, it's got this all the way back to 1970. And that's what's in the database. So that's a lot of data. But that means you can track data. Now, if it's a dispatchable plant, it's not all that interesting. Perhaps a nuclear plant, you could evaluate different trends and really do kind of some nice statistics on. But for renewable, it's got these categories of fuel codes, which were a real pain to get all right. But it's got water here, and eventually down somewhere it'll have some solar and some wind. Okay, so you take that data, and then once you have that data, it works with a whole lot of indirect functions, and the names changed a little over time, but it works with a whole lot of indirect functions. So for this power plant, this was, I think, a nuclear plant, and we can see how much production there was for each month. All right, and even to 2017. And the key thing is to get to 2016. Here's some hydro plants. Now what you do is this is on the Google link. Then you copy this. You just copy this file into a new file. And now let's look at this. And what I'm going to do is, oops, you didn't see that. We're going to compare the distribution, which I've done before, but I'm going to do this in much more of a summary kind of a way. Now, let me explain really where to find the files. In Chapter 5, there are two parts. One is conventional electricity, mainly dispatchable plants, and that's where I have all the marginal cost data, the spot pricing data, the kind of statistics and analysis for benchmarking and some levelized cost analysis and all that. And then renewable energy. And in renewable energy, there are some case studies, some costs, and I shouldn't have said that. And then we have some resource assessment data, a few little current topics, a couple of books, and resource studies. And in the resource studies, I have hydro, solar, and wind, really. And let's get the hydro one. And in the hydro one, I've got some other kind of studies that I've collected. But then we go to the generation database. And that generation database is this one we're talking about. Now, once you, we only want the hydro mover code. Whoops. So, we go to the summary sheet that we just made, and this just has all the different power plants, and it has oh my gosh, 10,000. 10,000. Making that list of power plants was kind of one of the real tricky things to do, to make sure it expands and covers all the years. Now we just put a filter on it, and then let's just select only the hydro plants. Okay. And oh, stupid thing, what an idiot I am there. And then once we have only the hydro plants, we just copy those. Okay, and we have, it seems that we have quite a few hydro plants. Okay, so you copy that and just paste this into our paste specialist values. And now we've got all the way to 2017. Oh, excuse the dog. Oh, gosh. Okay, that's my son's dog. Now, here I want to, some of the stuff that doesn't have much data. That data will not be anywhere near as good as the data that has the plants that have a lot of data. Now I try to count if you should be able to count if it's not equal to 0, and I was too lazy. What I did is I said, okay, I don't know how to make that count if, so let's quickly just make our own function. And if you make your own function, it's such a simple kind of thing to do. You just say count if it's non-zero, start with a counter, go from 1 to how many numbers or how many cells really are in the series, and then if the series, which has an array, is greater than 0, then increase it, otherwise don't do anything, and when you're finished with the loop, just see how many you've got. So this was, we put equal count non-zero, select the, hoping the dog doesn't bark again, and then double click. Okay, and then that we can just sort by that, and we can kind of look at all the. Okay, well, this is not a very good video, but I'm finishing it because it's I think it's worth telling you that I did make a little bit of an update on this. So this, and the dog is barking and everything else. It's kind of going back. So if we sort from largest to smallest with that little count formula, then we'll the first things on the list will be all the plants, in this case the hydro plants with a whole bunch, and then we look at our codes and we can start to see, well, this we needed a 2.7 DSCR for this one, because, and the 6 times for this one, and the 3 times for this one, and this has kind of got some real history. Oh no. So if we're comparing the average, if we're saying we want to see how much more buffer do we need from the average, you can see this is the real stopping point now, is that for hydro we need a big buffer. For, I'm pressing Control Tab, we just looked for wind. It depends on the wind farm. You can kind of see the different variations on what kind of buffer we would need. And then for solar, I said, well, okay, I did the same thing. Now for solar, there's a really sad story, and in that there aren't nearly as many plants. Okay, here's one with 3. We needed a 1.27 for this one, 1.05 for this one, another 1.05. You know, look at how much smaller the required DSCR is for that one. Okay, so that's how you get the data. I wish, you could do a whole bunch of your own stuff with the data. Okay, and it demonstrates. I hope you're looking at this thing and see just how much lower we can accept for uh, the DSCRs. Now, if you want to find this in the Google, I mean the website, you look down here and somewhere I have generation database solar and generation database wind and generation database hydro, and that is enough.